Hello, everyone. I'm happy to be back and I'm happy to have you again with me in this channel. Thank you so much for your support. There are now about or more or less 70 problems in this channel contained in 52 videos. So if you are a math contestant preparing for an upcoming math competition, you can use the materials in this channel to practice on, no? So, and if you are a math coach, then you can use the materials in this channel to train your contestants. So our first problem for this video is: let S be the set containing the consecutive positive integers from 1 to 90, inclusive. Now, partition S into 9 disjoint subsets, S1 up to S9, each of which contains 10 elements, and all 9 subsets have the same element sum. Okay? So, the sum of the elements of S1 is the same as the sum of the elements of S2, the elements of S3, and so on until S9. Okay, so how do you partition the set S? Okay. So we look at the sum of these numbers. You have 1 plus 2 plus 3 and so on up to 90. And our formula gives us this sum to be 90 times 91 over 2, or this is 45 times 91, and 45 is 5 times 9 times 91. So what do we get from these calculations? Well, the preceding calculations suggest a way of choosing the elements of each of the 9 disjoint subsets. Since there are 9 subsets, this common element sum must be, from the calculation, must be 5 times 91, which is 405. Also, moreover, for each subset, we must choose pairs of elements xy pairs of elements xy from S such that x plus y must be equal to 91. Okay. That is, there must be 5 pairs because there are 10 elements. Systematic way of choosing these elements is as follows. If you choose x, then y must be 91 minus x. So S1 is equal to, we start with the first value of x, which is 1, and each pair must be 90. Then the next value of x is 2, and each pair is 89. Then we have 3, then each pair is 88. And then we have 4, and its pair is 87. And then we have 5, its pair is 86. So we now have 10 elements for S1, and their element sum is equal to 5 times 91. So now S2 would be, the first element now would be 6. And its pair is 85. And then 7, its pair is 84. And then 8, 83. And then 9, 82. And then 10, 81. Okay. And so on. Okay. S3 would be, the first is 11, and then its pair is 80, and then 12, you have 79, and so on. And then the last, this would be 15, and then 81 minus 5, that's 76, and so on. I will not go into the details anymore, but S sub 9 should be 41 and 40, the first pair, and then 42, 39, the second pair, and so on until the last pair is 45 and 46. So these are the subsets that partition the set S, each of whose element sum is the same as the others. Okay. So now we go to the next problem. A function f satisfies f of x equals f of x plus 7 times f of 5 minus x is equal to x squared minus 2x plus 2 for all real numbers x. Find f of 8. So here, switching x and 5 minus x, we have, or switching the roles, of x and 5 minus x, we have f of 5 minus x plus 7 f of x equals 5 minus x squared minus 8 times 5 minus x. Okay, sorry, this is not 2x but 8. Okay, so 8 minus 5x, x, 8 times 5 minus x plus 2. And when you perform the squaring here, you have x squared minus 10x plus 25 minus 40 plus 8x plus 2, which simplifies to x squared minus 2x minus 13. This is equation A. Then from the given equation, f of x is equal to x squared minus 8x plus 2 minus 7 f of 5 minus x. But from equation A, f of 5 minus x is equal to, okay, so we plug in the expression for f of 5 minus x from A. So we have x squared minus 8x plus 2 minus 7 times, you have x squared minus 2x minus 13 minus 7 f of x. Okay? Then removing the brackets, we have x squared minus, and performing the multiplication, the indicated multiplication, you have minus 7 x squared plus 14x plus 91. Okay, 7 times 13 is 91 plus 7 times 7 is 49 f of x. And then we have, from which we obtain from which we obtain 48 f of x is equal to 6x squared and then minus 6x minus 6x. Is that right? Okay. Minus 6x minus 89. Wait. Minus 93. Okay, minus 93. From which, or here, f of x equals 6x squared minus 6x minus 93 all over 48. We can still reduce this to a simpler expression, f of x. Both numerator and denominator are divisible by 3, so this is 2x squared minus 2x minus 31 over 16. Over 16, yes. So, f of 8 equals 2 times 8 squared minus 2 times 8 minus 31 over 16. This is equal to 8 squared is 64 times 2 is 128 minus 16 minus 31 over 16. Okay, so this gives us 81 over 16. Okay. Another solution this without finding f of x, without finding f of x. Okay. Now, with respect to 7, with respect to sorry, not 7, but where is that? 5. With respect to 5, eight and negative 3 are complementary. So when x is 8, we have From the given equation, we have f of 8 plus 7 f of negative 3 equals 8 squared minus 8 times 8 plus 2 equals 2. And when x equals 3, when x equals negative 3, we have f of negative 3 plus 7 f of 8 equals 3 squared, negative 3 squared minus 8 times negative 3 plus 2 equals 35. 24 plus 2 is 26 plus 9 is 35. So from these two equations, this becomes a system of linear equations in two unknowns. So you let x or a equals f of 8 and b equals f of negative 3, and then solving just like you solve linear equations in two unknowns, then you will get f of 8a solving, we get fa, which is f of 8, is equal to, just like in the first solution, 81 over 16. Okay, so that's it for our problems for this video. Okay, so we have a challenge for you before we leave. Okay, the challenge is consider the arithmetic progression or arithmetic sequence 1, 9, 17, 25, 33, and so on until 2025. And number n is the sum of 17 distinct elements of the arithmetic progression. How many distinct possible values of n are there? Okay, so n is the sum of 17 distinct elements of the arithmetic progression. Then you take another 17 elements, you have another sum. take another 17 elements, then you have another sum. How many are there of these sums? So that's the challenge. The solution to this problem will be given in the next video. So that's it for now. I hope you enjoyed our discussion today and you learned something from it. And I hope to see you in the next video. So for now, goodbye, be well, and may God bless you.